Okay. So it says a rational function y is equal to gx by hx, where hx is not equal to 0. We will have a vertical asymptote at x is equal to a if h of a is equal to 0 and g of a is not equal to 0 when the function is in simplest form. Fine. So we have seen this earlier also, though we have not used these words, but we have seen this earlier that let me take the pic of this.
Yeah.
So here, first of all, a rational function which is given as y is equal to gx upon hx, where definitely the denominator cannot be equal to 0. So if hx is equal to 0 at x is equal to a, which means that h of a is equal to 0, then what we say that and also g of a is not equal to 0, and it is in its simplest form. What it means actually is, for example, if it is given as y is equal to x minus 2 by x plus 1 whole square into x minus 2. So this is not in its simplest form. When will it become in its simplest form? When the common terms will get cancelled. So you will cancel x minus 2, then you will get 1 by x plus 1 whole square. This is in its simplest form. Of course, 2 is not in its domain. We'll discuss that later. But right now, this is its simplest form because the numerator and denominator had a common term which we will cancel. Now, here you can see that at x is equal to minus 1, this denominator h of x, which is x plus 1 whole square, is equal to 0. So we will say that at x is equal to minus 1, the function has vertical asymptote. This function has vertical asymptote. So they have shown a graph also. The graph is something like this, that it is y and x axis like this. And the graph is in this manner, going like this. And then it is going like this. And there is a asymptote here. This is some other graph, not the example which I have taken.
Okay.
So you can say that here there are two vertical asymptotes. One is the y-axis, which is x is equal to 0. This is a vertical asymptote. And another is x is equal to minus 2. This is also a vertical asymptote. So these two vertical lines, x is equal to minus 2 and x is equal to 0, are vertical asymptotes because the rational function has denominator which is becoming 0 at these points and it is in its simplest form. So this is what it is trying to say. You can write this. Let me scroll up from here.
Yeah, done, sir. Can you scroll down? Yep. A bit up, sir. I didn't write that equation.
Sorry?
Can you go a bit up? I didn't write the y equals. Yeah, just like this. Done, sir.
Now you can share. Okay. Determine the vertical asymptotes, if any, for the following function and discuss the behavior of the function near these asymptotes. So, would you try this? Or should I first give you some hint?
I'll try, sir.
So, I will just giving you an initiative that what you have to do is the denominator one. That is the important. So, denominator one you have to factorize, see where it is zero, and also see whether it is in its simplest form or not. Then you will find the vertical asymptote.
Okay.
So I'll be back in 5 minutes. You just try
Okay.
this.
Okay, sir.
Yes, Satya, need to ask anything?
Sir, I only got till the zeros. I got x equals 2 and minus 1.
X equal to 2 and minus 1. Yeah. Now there is a catch here. Is this in the simplest form?
No, this one is not in the simplest form.
So what will be the simplest form of this?
Of this whole equation?
Yeah. It is not equation, it is a function.
Sorry, yeah, the function. Uh,
This thing, na? Fx is equal to minus 2x plus 4, I think, upon x square uh, minus x minus 2. Is this given there?
this, yeah, this is the one that's given this.
And denominator you got as after factorizing. What are the factors of the denominator? You just told me the roots, na? So what are
X,
the
yeah,
factors?
so that will be x equals 2 and x plus 1 and x minus 2.
Right. And what will be the numerator? Can you take something common from the numerator?
2,
Minus 2, can't we take?
yeah, minus 2. So that will be x minus 4, 2.
So this x minus 2 will get cancelled now.
Yeah,
So this is the simplest form.
okay.
So I just gave you an example, and just you saw in this slide, it has come. So this is the simple form. So now you have to decide the asymptotes. What will be the asymptote? So you won't take 2. You will take only x is equal to minus 1, because that 2 is getting cancelled.
Yeah.
Where will be the asymptote? Which vertical line?
Uh, the negative 1.
I will take this as x is equal to minus 1. This will be the vertical asymptote. Now, can you tell me the graph? What will be the nature of the graph? How it can be drawn? So this vertical asymptote is dividing this plane into two parts. Forget about y-axis right now. One part this, one part this. Well, y-axis is lying in this region. So right now we are not concentrating on this y-axis. We have two parts. One before x is equal to minus 1, one after x is equal to minus 1. So if you see the right portion, so for x greater than minus 1, this is x greater than minus 1, this is x less than minus 1. So for x greater than minus 1, which means x plus 1 greater than 0, this function of x, which is minus 2 by x plus 1, will be negative. Won't it be
Yeah,
negative? Because it is minus 2 by x plus 1. And if you take x plus 1 less than 0, then function is minus 2 by x plus 1, that is negative above and negative below also. Then it will become positive. So the function on the right is negative and on the left is positive. So negative means it is below the x-axis. So curve would go like this. And here the curve would go like this. But still, this is not the exact graph, because one important thing is to be mentioned here, which they may deal later, but I'm telling you now, because after cancelling x minus 2, you are getting this. So this x is equal to 2 is also a 0 of the denominator and numerator. Though it has got cancelled, but x is equal to 2, the function is not defined. X is equal to 2, the function is not defined because denominator will become 0. Why is it so? There is difference between two things. If we talk about minus 2 by x plus 1, it is different from minus 2 into x minus 2 by x plus 1 into x minus 2. Now, how is it different? You will say that we are cancelling x minus 2 and we are getting the same thing. But here, you can cancel them only if we have studied in limits. We can cancel them only if x minus 2 is not equal to 0. That is, x is not equal to 2. So this will cancel and become minus 2 by x plus 1 if x is not equal to 2. Whereas here, it is defined for x is equal to 2 also. So that point 2 is a point where this function is not defined. So what we will do here, while drawing the graph, we have to keep this point in mind, which they will tell later, I think, that at 2, you will mark 2 here. When you will take this curve like this, you will have a hole here. They have talked about it in the first or second slide about hole. So this hole will be there and this will go like this. It won't be like this, that this is going like this. This is like this. This is this, and this is this, then hole, then this. Because that 2 is also playing a role. So have you understood what am I trying to say?
Yes, sir.
Yeah. So at 2, though we have cancelled x minus 2, and that will not become an asymptote, because for asymptote, the numerator, it should be in the simplified form. So it is not asymptote, but it is a whole. So we will talk about whole in further slides, I think. At 2, it is not defined because there is difference between this two things you have to understand. There is difference between minus 2 by x plus 1 and minus 2 into x minus 2 by x plus 1 into x minus 1. Though x minus 2 is getting cancelled here, but it can be cancelled only if x is not equal to 2. Then only you can write it like this. That means that x is equal to 2, it is not defined. So this whole thing you have to write.
Okay. Yeah.
What is the duration of today's class, Satya?
Today is 1 hour, sir. Yeah, none, sir. Can you scroll down?
Yes.
Yeah, done, sir.
Okay. Now you can. Determine.
Yep.
Okay. Determine with support an equation for each rational function of the form y is equal to gx for each x that satisfy the conditions a whole exists at 4 comma minus 2 and a vertical asymptotes occur at x is equal to 0. Okay. So whole is at 4 comma minus 2 and vertical asymptote at x is equal to 0. So the figure may be something like this. If we don't want to draw many complicated figure, possible figures are many type of, but we go to what simple figures we are doing. So x is equal to 0, they are saying the asymptote, right?
Yeah.
So what is x equal to 0? It is the y-axis.
Vertical asymptote occurs at x equals 0.
And where is the whole?
Whole x is at 4 and minus 2.
4 and minus 2, no, 4 comma minus 2.
4 comma minus 2.
So this is 4 and this is minus 2. So here there is a whole. Now if you want to make such type of function, so what you can do, you can think of a function which has vertical asymptote at x equal to 0. That means we have denominator x there. Okay.
Yeah.
And this makes the vertical asymptote x is equal to 0. And what we can more do, that we can multiply with, since at 4 you are getting the whole, right? This whole is at 4, x is equal to 4. So x minus 4 you multiply in the numerator and in the denominator. So that will give you the whole at x is equal to 4. It will not be an asymptote. If you wrongly do this 1 by x into x minus 4, then x is equal to 4 will also become the asymptote. That you don't have to do. You have to find whole at x is equal to 4. That means you will multiply by x minus 4 in the numerator as well as in the denominator. You got till here?
So
Have
the
you got?
whole exists at, oh yeah, I understood this.
Okay. Now one more thing is remaining, that at x is equal to 4, the value has to be minus 2, approaching minus 2, which means if you cancel x minus 4, you get 1 by x, right?
Yeah.
And that should be minus 2. So what constant you should put there? So I think if you put x is equal to 4 here, that is 1 by 4, and you want minus 2, so I think you have to put minus 8 here. So that means it is minus 8 by x, that is minus 8. So finally, the function would be minus 8x plus 32 upon x square minus 4x. So this is written like that. This is the simplified one. So when you factorize, it becomes minus 8x minus 4 by x into x minus 4. And when you write x minus 4, when you will cancel x minus 4, that is when x is not equal to 4, it will become minus 8 by x in simplest form. So one thing you have to show, that if it approaches 4, because it cannot be 4, if it approaches 4, then in that case, if limit x approaches 4, then this minus 8 by x, which is the simplest form, will become minus 8 by 4. That will be minus 2. So this will be the value of y of the whole, because at 4 it is minus 2. So that minus 8 you have to manipulate there and put there. You can't put minus 6 or 7 or anything else. You have to put minus 8. So after doing a lot of this, you can find the curve, and that curve would be, you have two regions, right? Minus 8 by x is there. So x equal to 0, right portion and left portion. Since there is a minus sign, it would go below and it would go like this. It is not touching the x-axis. There is a hole, and then it is, the curve is continuing like this. And here it would be. So this is all. We can give the example as.
So is that it?
Yeah.
Okay.
Have you understood?
Yeah. Yes, sir.
Which university you are doing this course from?
No, it's not. It's for the university application, so it's not exactly one university.
Okay. What is that set of universities exam called?
So it's like basically like for in Canada, math is compulsory for a science stream.
Okay.
So so like there's two courses which I'm doing now, which is functions and calculus and vectors, right?
So this is being prescribed by the university itself.
No, it's basically like for international students who want to study and pursue for higher education in Canada, they have to do like a course. Like example, like in India we have math, psychology, like different subjects in 12th grade, right, sir?
Yes, yes.
Like that, instead of going to school, they can give like an online certificate for just one subject that you don't have.
So the I understand who is conducting this
Or
ex
it's any virtual high school, like online education site of
so
Canada.
the material and this from where you are getting this one.
From the online site. I am using the one I registered is Ontario E Virtual High School
So where it is based?
in Ontario, Canada, Ontario, Canada.
Canada and Ontario. So it is a physical uh, entity also, or it is just a
No, no,
virtual?
it's only virtual.
Okay. So it is this is being recognized by the certificate given by Ontario is being recognized by the colleges.
Yeah, yeah, yes, sir.
So which colleges will recognize it? Like colleges of Canada and universities of other countries also.
No, I think yeah, they will once I get a certificate, but this is mostly only recognized in Canada, only for
O-
Canada.
Okay.
So can you scroll up? No, no, it's fine. No, this is fine, sir.
Everything
It's
is
fine.
here.
Yeah, yeah. Yeah, done, sir.
Okay. So I think let's see what is more, but we won't be able to do more. Let's see.
See this, sir. One slide,
Okay,
two.
horizontal oblique asymptotes. Okay, so we have horizontal asymptotes, then oblique asymptotes. So tomorrow's class, tomorrow do you have class?
Yeah. No, 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 sir. I'll be go. No. Tomorrow I won't. Okay.
Okay. So day after tomorrow we'll complete it. Okay.
Okay. So yeah, this is the site. You see.
Learn.oeshighschool.com. Okay.
See, Ontario E Secondary School.
Ontario East Secondary School. Okay, so they have, this is a good school. That's why they are giving such a good content. And I think, mm, though they have not a physical entity, but still they are having such a recognized certificate and all. So that means they are quite
Yeah.
advanced in e-schooling.
Yes, sir.
And in fact, if I see the content, their content, it is very much different from the content which we do in India. Though we do the same thing, but in a very different way. Actually, I don't know because it is high school, then it is same as it is written also grade 12. So we also
Yeah.
do the grade 12 here, but
Mhm.
very much different approaches there. We have very difficult questions here, like in JEE Advanced, we have very
Yeah. Yes, sir.
difficult questions, but we don't go much into the basic clearing of the concept step by step.
Okay.
We more often jump into the difficult questions, and here they are very